Hello everybody and welcome back to another video on discovering code. आज हम सॉल्व करने वाले हैं एक नया प्रॉब्लम जिसका नाम है sum of medians and आज मैं कुछ नया ट्राई करने वाला हूँ. I have my tablet here and मैं उसको कनेक्ट करके मैं ट्राई करना चाहता हूँ जैसे वो फैंसी यूट्यूबर्स करते हैं to draw and to explain and all and to brainstorm. So that would be my aim to implement that in this video, trying things in a different way this time because एक स्केली ड्रॉ पे ड्रॉ करना is very hard and एक माउस से ड्रॉ करना उससे भी ज़्यादा hard. And I mean कुछ लोग होते हैं talented enough that can draw on a mouse on a skelly draw, but not deviating from the point, let us get us into this video. Let's start the timer. Here we go, and now let's read the problem. A median of an array of integers of length n. Okay, let me do one thing. मेरे को इसको duplicate करके यहाँ पे डाल देना दो because ये वाली स्क्रीन भर जाएगी अभी जब मैं टैबलेट लाऊंगा तो. Alright, a median of an array of integers of length n. एक काम करता हूँ मैं स्टार्ट ही कर देता हूँ. Let us begin smart view. No, not there. Here. Let's go. Let's go. Hello. It's taking a while. There we are. Let's try again. Okay, but I can't full screen. Okay, let me just full screen this. Best. Awesome. All right. Now let's open the Notes app and let's start going through the problem that we have. So the problem state a median of an array of integers of length n is the number standing on the n by 2 rounding up position. Okay, so we are given a median which is placed inside an array of length n, and this median is positioned at the n by 2 rounded up, right? Yeah, so rounded up seal position so that represents the position, this position, and positions are numbered starting with 1. So 1 2 3 4 5 6 like that. Okay, for example, a median of the array 2 6 4 1 3 5 is equals to 3. Okay, maybe I should do one thing. I should make this smaller, bring this up here. Is that better? No, I don't think so, right? Yeah, I think that's enough. For now, I think we can increase the size. Yeah, this is better. And close that. Okay, so we are given for example, we are given this array 2 6 4 1 3 5 and the median is equals to 3. Now where do we see 3? It's this position, which is 1 2 3 4 5 6. So total number is 6 by 2 we get 3. Huh. Oh, sorry. Wait. Median of an array of integer of length. Median of an array of length n, of integer array of integers of length n is a number standing on n by 2 position, rounding up. We have 6 here. Oh, okay. Yeah, that makes sense. Yeah, that makes sense. My bad. Okay, so median is 3 and the median, wait, median is 3, right? Median of the array is equals to 3. Given two integers n and k, non-decreasing array of n into k, divide all numbers into k arrays of size n such that each number belongs to exactly one array. Divide all numbers into k arrays of size n. You want the sum of medians of all k arrays to be the maximum possible. Okay, first of all, I don't even understand the first description that it has given me, which is I'm very confused in the position aspect of the median and the actual position. Like in the example that it has given us, 264135, right? It's saying that the median of the array is equals to 3 and that the position of the median is the number standing on n by 2, rounding up. So you tell me, we have 6 elements here. 6 by 2 gives us 3. No need to round up because we don't have a float number or double number, a decimal number or a factor number. Uh, so I get 3, and at the third position there is 4, but the median is 3. So what's going on? I mean, I need to first understand this. Positions are numbered starting with 1. I have done that. 1, 2, 3, 4, 5, 6. Median of an array of integers of length n is the number standing on n by 2 position in the non-decreasing order of its element. That's the thing I missed. Non-decreasing order, which means increasing order, which means ascending order. So this is not a non-decreasing order. What will be a non-decreasing order is this. Sorry. There you go. And now here, the third element is 3, which matches the median. Okay. So that was the part that I was missing. Okay. All right. Mm, 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 mm. Okay. So uh now we are going to see the next part. Given two integers n and k. Okay, we are given an n, we are given an k, and non-decreasing array of n into k integers. So size of array given to us will be n into k, and it will be non-decreasing, which is what we want, right? I'm gonna write, okay, decreasing. Sorry, my handwriting has not improved even though my tech has, Okay. So divide all numbers into k arrays of size n such that each number belongs to exactly one array. So each number belonging to exactly one array, does that mean we would have duplicate elements? Is that something that's gonna be there? I'm looking at the examples and I don't think we have duplicates. So okay, we don't have duplicates. But it is a guaranteed that the array is non-decreasing, but as we can observe uh, in the input, we can see that a1 is greater than or equal to, sorry, less than or equal to. So what that equal to means is that duplicates are allowed. So duplicates are allowed. Uh, and what else? You want the sum of medians of all k arrays to be the maximum possible. So what we need to do is maximize the medium of each array. Maximize median of each array. Oh, my bad. Array, which in turn will increase the sum automatically. So, okay. So now how do we divide all the numbers since we are going to? Okay, so we will be given a non-decreasing array. So that is clear. And we will be given n into k so that we can easily divide uh, arrays into k parts of n sizes. Right, right. I don't know what I mean, we just, hmm, let's see. Let's walk through an example uh, and let's see what's up. So, uh, 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 should I make it like this, horizontal? Oh, that made it smaller. Okay. Okay, lesson learned. All right. So let's take the first one in which we have n, or is that k? So let's look at the input. The first line of the description of each test case contains two integers, n and k. So this n is 2, k is 4. And the array that we have is 0, 24, 34, 58. Then we have 62. Then we have 64. Then we have 69. And at last we have 78. Great. Now, if we do it the normal way, is that we need two arrays and what was the line? Divide them into k arrays. Okay, so we need four arrays, each of size 2. And as we can see, we have 8 elements. So just do this, do this, do this, and we have 4 arrays. Uh, is it given that we have to okay, so the median here is 24, 58, 64, 78, right? And sum it all up. And is that what we got? Uh, wait, what? Okay, so the median, sorry, we had its own. Okay, my bad. We have a definition which states that 2 by 1, which gives us 1, and that is the median. So this gives us what? 0. Is that correct? Yep. And this gives us 34. This gives us 62. This gives us 69. We sum it all up, we get 165. And that is the answer. I have no idea what we... Is there actually... Wait. Okay, this was... Do we need to do any switching of elements or something? Or just divide them and find out the... I mean, okay. Okay, let's go through another example. That will make things clear. Uh, let's take the third example because second is too small. So n is 4, k is 3, and then the array is 2, 4, 16, 18, 21, 27, then 36, then 53, then 82, then 91. Okay, this one is a bit large. 92, then 95. There we are. Okay. Now we need 3 arrays of size 4. Again, just do this, and that's that. We get, this is 4, right? 4 by 2 is 2. So we get 4, we get 27, we get 91. Is that correct? No, that is not correct. And that is the point that I wanted to uh, understand, is that we can jumble the elements to make sure that each array gets the max element at that position. Is that what we have done? I do think so. Okay, so we have done what? To bring 92. So what I can see is that 2 was brought to 82's position. 2 was brought to 82's position, right? And then 4 was brought to, where does 4 go? 4, 36. Uh, so you know what? Let's write it like that. So 2 and 82 swap places. So what it would look like? 82. We're gonna write it like that. 4, 16, 18, 82 division 21, 27, 36, 53 division 2, 91, 92, 95. Right? So this is what happened by after doing one swap. So what did that change? Nothing. 92 was there, 92 will still be there. What was the point? The point was uh, now we change. Okay, let's not think it like this and let's change our perspective a bit. How would we do that? What we actually need to do is that we need to identify the median's place. So like we did, right? Median's place is what? N by 2. What is the k here? K I think was 3 and then n was 2. Sorry, n was 4 I think. Yeah. And then n by 2 means 4 by 2, which is 2. So this position, we need to maximize this position. How can we do that? Great question. I think Mm, 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 mm. Can we have maximum possible sum of all k errors? Okay. 2, 91, 92, 95, 4, 36, 53, 82. Okay, let's. mm, mm, This is the input array, and this is the answer array that the test case tells us, sample test case. 92, 95, 4, 36, 53, 82, 16, 18, 21, 27. Okay. Okay, I think I can see the problem a little bit, I think. Okay. So if we take this particular example, we need four medians, right? And we need to maximize them. That means if we need four medians and in each array we will have four elements. That means that there should be one element that should be smaller than the median, and then two elements that should be greater than the median, right? And we need to find a configuration in which we can maximize this median while satisfying this condition. I think that is all this is. And if we find such elements, then we can easily return that configuration. And if we don't, then we always have the fallback of the initial input, which is the base that we had, like this one, where we just pick the median elements from the input array. Because if we can't configure right in that, then we just do this. But if we can, and if we can find such elements in which we can satisfy this condition, then I think that would be the answer, right? But the solution for this might, mm, how can we do this in O of n? I mean, we haven't done the time complexity, so let's do that. Um, okay, that does not look like complexity. Let me write it again. Okay, better, much better. Okay, so we are at 1 second. 1 second, bro. Second for test case for the whole test. So per test case, we have how many tests do we have? The next two t lines contains it. Okay, we have t is equals to 100, so not a lot. So I think we have some breathing room, right? Mm, each element could go to 10 to the power 9, but it is guaranteed that the sum of n into k does not exceed 2 into 10 to the power 5. Okay, so this means 10 to the power 8 or 9 will take 8 ops, right? And if we subtract this, so for each test case we get around 10 to the power 6 ops. But as we know, 2 into 10 to the power 5, um, sum does not exceed that. and mm, think we can do this as overfan solution. Can we not? A single pass? Mm, we don't need to do anything, to be honest. Uh, we just need to return the sum. The sum can be, we just need to identify the sum basically. Identification is the main thing. Uh, of medians. That's the main thing. When we identify, we can easily do the sum. That's a one liner. Mm, so for identifying, how do we do that? How do we identify in one pass? Hmm. That's a good question. We'll have to think about it. Uh, all right. I think I got something. So now that we know that we need to only figure out the one element in front and two elements from the back, what if we just focus on this and we start from the back? So originally we had this array, right? So let's start from here. Now we know that we need two elements which should be greater than our first biggest median. So we take two elements. What is going on? We take two elements, then we pick this one. This is our median. Then after this, we need to skip two elements for the next median plus this current one. So we need to skip three. So this would be, we can, let's call this n. No, n is taken. Let's call this m. So this thing here is m. Now we need to median. So we need to do m plus 1 steps again in this direction. So we need to skip this. Sorry, we need to skip this. We need to skip this. We need to skip this. This is our median again. Oh, sorry. My bad, my bad. We need to we count that. We skip. This is our median again. So three steps. Uh, mm, this is, yeah. Then we do it again. 1, 2, 3. And then this is our median again. And I think so. This is what we have, right? 91, 36, and 18. So there you go. Goddamn. Okay. All right. And this 2 can be changed to uh, uh like we found this, right? Where is it? This 2. We found this 2. Then we got this 2. Uh, we found this 2. So that means at the 2th position, the median is there. And we also know the array's length, which is 4. 3 minus 2, which is 2. And that explains that two elements should be greater than our median. And one should be smaller, basically, implied. This one is implied if this is followed, and if I don't know about this. I mean, it's better if we go backwards because we want the maximum, right? So the maximum is always at this end of the array instead of this. And one element after, if we do that, we'll get 4, then 27, then sorry, 4, then we'll get 21, something like that. So it will be, it will not be correct because it won't maximize since the array is non-decreasing in nature. Okay, so let's move on to the code part then. I will close this. Let's close this problem out. All right. Let's remove this. Let's use our function that we have, cf java. There you go. Let's copy this. Let's paste this here, and let's name this that. Let's remove this and this, and then let's solve it. I need to solve it quickly. I need to go to the airport. Okay. So what's our input? 2 in the next 2 into t lines. So this should be 2 into t, right? Or not. That's fine. It's just telling us the number of lines that it would contain. Int n is equals to fr dot next int. Oh god. Oh. int k is equals to fr dot next int. Then we have the second line of the description contains n into k integers. So let's initialize an array of n into k size. It's 10 to the power 9, right? It's 10 to the power 9. I'm gonna do this very quickly because I have to go to the airport. So I'm just gonna go and complete this in 3, 2, 1. All right, so as you can see, I have completed the function. Here's the step element that I just wrote, and then here's the step that we're gonna increase after after finding one median. And so yeah, that is how it is. We add the actual last element first, and then we iterate again using step, and we move in the opposite direction. We decrease the current count with the step, and then we keep adding it to total sum. Then we print the total sum, and as you can see, it is identical to the one that we have here. I'm gonna go and submit this, and as you can see in my voice, I am very, very in a hurry because I need to go to the airport and pick someone up. So come on, bro, please be quick. I know Java ain't quick. Oh, what the hell. All right. Did I save it? Of course, my dumbass did not save it. So I have to do it again. My God, not when I'm on a hurry. No, that's the wrong. All right, go, 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 go. Go, go, go. I said go. Please go. Please go, man. It's 40 minutes now. Please go, man. There we go. Beautiful. Solved. Solved, 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 solved. All right, guys. I will see you in the next one. Until then, take care. Bye-bye.